Hello everyone, welcome to today's class. This is teacher Simon again taking you through Cambridge International AS and A-Level Mathematics paper 4-1 for May, June 2023, and this is part 2 for questions 5 to 7. Question 5, this is coming from resolving of forces. They are saying that for coplanar forces, coplanar means they are in the same plane. So they act at a point, then the magnitudes of the forces are F newtons, 10 newtons, 15 newtons, and 40 newtons. The directions of the forces are shown in the diagram. Given that the forces are in equilibrium, find the value of F. Now, we are supposed to resolve these forces that are not either vertical or horizontal. So we are supposed to close in this one, and then we also open it here, okay? You close in this one, you also open it, okay, there. And if you have been following in all the previous videos, I've always said that closing is cosine, okay? And then opening is sine. And we have always drawn a smart diagram like this. So resolve the forces horizontally. So on the horizontal here, we are getting 10. So we have 10 newtons. But there is also this one closed in here. So it is going to be F cos of theta, F cos of theta. And then when you open it up here, so that vertical, it is going to be F sine of theta. And then we have this one up here. This one, close it in here. That one is going to give us 40 cosine of 60. And then when you open it up to this, it will give us 40 sine. So we write here 40 sine of theta. I think nothing else to do. So this is 90 degrees. Now, resolving the forces vertically, we can see that whatever goes up. So since they say that the forces are in equilibrium, that means the resultant in the x direction is 0 and the resultant in the y is also 0. So, by the way, down here we have the 50. There's also 50 here, newtons. Then, this is not sine theta, by the way, 40 sine 60 degrees, pardon me here. 60 degrees. Now, vertically, we have these ones equal. Those that are going up are equal to the one that is going down. So we shall have 40 sine of 60 plus F sine theta. Then this one is equal to 50. Okay, so we can make F sine theta the subject. F sine theta is equal to 50. Sine of 60 is root 3 over 2. So that means we shall get 20 root of 3, okay, from here. Then that is my maybe equation 1. Now I go horizontal. So horizontal forces, we have F cos theta plus 10. These ones here are equal to this one here. Okay. Then these ones are equivalent to 40 cos of theta of 60 degrees. Now F cos of theta shall be equivalent to cos of 60 is a half. So a half of 40 will be 20, then minus the 10. So meaning F of cos of theta shall be equivalent to 10. And this is the second equation here. Then I can put these two together. We solve them simultaneously. If I get the equation 1 and then I divide by the second equation, I can eliminate the F, then I remain with the theta. And sine over cos gives us a tan, right? So we shall have F sine of theta over F cos of theta. This one shall be equal to 50 minus 20 root of 3. Then we divide by 10. This one will even simplify to 5 minus 2 root of 3. So that means we have tan of theta, which is equal to 5 minus 2 root of 3. So what will then be theta? It's the arctan of 5 minus 2 root of 3. So when we put this in the calculator, we get the arctan of 5 minus 2 root of 3. That is 56.9 to 1 decimal place. Okay, 56.9. Theta is equal to 56.9 degrees to 1 decimal place. Always remember to put degrees. If you don't put it there, then that means that the angle is in radians, yet you have calculated it in degrees. So be very careful there. Then we can substitute and we get the value of f. Okay, the value of f, when I substitute, I can use any of the equations. So f here, maybe if I use the second one, f is going to be equal to, let me use this one here, 10 out of cos of theta. Okay, so f is going to be equal to what? So I get my calculator, then I will say 10 out of cos of that angle. We just say, if you pressed answer, just a cos of the answer, and then you get 18.3 to 3 significant figures, 18.3 newtons. That is to 3 significant figures. But be given instead that f is equal to 10 root 2 and theta is equal to 45. Find the direction and the exact magnitude of the resultant force. I will draw again my diagram here because a few things have changed. Okay, I will have this. Then, of course, this is 90. We had a 50 down here. Then let's check for these others. We had f cos theta, then the 10. Okay, f cos theta, but they have said that theta is 45. So we have 10 here, and here we shall have f, which f is 10 root 2 cos theta, so we shall put cos of 45. And then up here we shall have 10 root 2, that is f sine theta, which theta is 45. And then up here we were having 40 sine 60. Okay, so that angle remained 40 sine 60. Then this way we have 40 cos of 60. Now let's look at the resultant in the y direction. So Ry is going to be, since now the system is not in equilibrium, I can't just say that this is equal to this. Okay, so we need to check out which one is actually bigger. Cos sine of 60 is root 3 over 2, so that will be 20 root of 3. How about when I add 10 root of 2 and then I multiply that by sine of 45, which is 1 over root 2. Is 1 out of root 2. Of course, that root 2 goes. So we have 44.6, which is less than the 50. So that means the resultant in y acts downwards, okay, because it goes into the direction of the bigger force. So we shall have now 50. You subtract whatever is going up. 40 sine 60. Then plus 10 root 2 sine 45. And this one we have seen that it is 50, then minus. Inside here we have 20 root 3 minus the 10. So which can come to 40 minus 20 root of 3. Then how about Rx, the resultant in the x? Is this bigger than what is this way? So let's check. Cos 45 is 1 over root 2, so it will cancel that root 2. So we shall have 10, then plus 10, which is 20. And this 40 cos 60, that's a half of 40, which is 20. So that means this way we have 20, and also this way we have 20. So that means Rx is what? 0. Okay, so Rx is 0, but you can show it here. You don't just write it is equal to 0. 10 root of 2 cos of 45 Okay, then plus 10. If we subtract 40 cos of 60, we are getting 0. Okay, 0. Then after that, so that means the resultant of the forces only acts downwards here. It is the Ry. So the resultant force is going to be equal to Ry. So what does it give us? 40 minus 20 root of 3. And they said exact magnitude of the resultant force. So this is the one here. We don't do anything on it. It's exact. Don't write your decimals. Okay. Then the direction, it is in the direction of this 50 Newton force. So I will say in the direction of the 50 Newton force. This is just moving southwards, as simple as that. Question 6. Two particles P and Q of masses 0.2 and 0.1 kilograms respectively are attached to the ends of light inextensible string. That means it cannot be stretched and its mass is negligible. Then the string passes over a smooth pulley at B. That means there is no friction here. The string passes over a smooth fixed pulley at B, which is attached to two inclined planes. Okay, particle P lies on the smooth plane AB. This is very important. That means there is no frictional force. Okay, which is inclined at the angle of 60 degrees to the horizontal. Particle Q lies on a plane BC, which is inclined at an angle of theta to the horizontal. The string is taut. That means it is straightened, and the particles can move on the lines of greatest slope of the two planes. Part A, it is given that theta is equal to 60 degrees. Okay. The plane BC is rough. That means there is frictional force mu r. Okay. The plane BC is rough, and the coefficient of friction between Q and the plane BC is 0.7. The particles are released from rest. Determine whether the particles move. So to determine whether the particles move, all I need to do is to find the acceleration. If the acceleration is there, then that means that the particles will move. Now let's look at the forces which are acting on these particles. Since this is a string, there is tension generated in here, and there is also the same generation generated there. Automatically, there will be tension here, okay, opposing there on the pulley. And then for any inclined plane, there is always mg sine theta. So 0.2 g sine of 60 degrees. And also for this Q here, there is going to be that mg. Okay, there is going to be that mg. So 0.1 g cosine of theta. Okay, but there is also mu r, because they said that BC is rough. Okay, so there is frictional force, and friction always acts in the direction that opposes the motion. Okay, all right. Now, what else do we need? I think those are the forces that we need. We need to find R. So the normal reaction is here. So here there is the vertical component of the weight, which is mg, and the m is 0.1, then g, then cos of theta. And since there is no vertical motion on this plane, then that r is equal to 0. There's no motion, vertical motion, which is perpendicular to the plane. Okay, so r is equal to 0.1 g cosine of theta. And we are given theta as 60 degrees. Now let's apply. Let's look at the forces which are acting on Q here. So since Q is 0.1 kilograms, it is expected to move up, okay? Because it is lighter than P here. So we expect P to move downwards, okay? Now, using F, which is equal to MA, we shall now have, remember our R is on Q, 0.1 g cosine of theta, which theta is now 60 degrees. Okay. All right. Now, T, the tension, is now bigger than the tension is bigger than this one here. okay? So minus mu r, then minus 0.1 g. Pardon me here. I made a mistake here. This one is supposed to be sine theta. The horizontal component of the weight here is sine of theta, not cosine. Please pardon me there. And then this is 0.1 g cosine. Again, it is sine of theta. Then this one will be equal to the MA. The mass is 0.1 of the A. Okay. And then let's go to Q. What happens to P? So for P, we are having, since it is going down, that means the mg sine is bigger than the tension. So 0.2 g sine of 60, okay? Then minus the t is equal to, the mass is 0.2 a. So to get the acceleration, I will add this one such that I eliminate the tension, because this one is positive and this one is negative. You see that? Now, I continue, and then down here you have 0.2 times 10. Sine of 60 is a half, okay? So 0.2 times 10, that is 2. Divide by 2, we get a 1. So this one here gives us a 1. Then mu is given as 0.7. So we shall have minus 0.7. R is 0.1 times g, then cosine of 60, which is a half. Okay, then there is 0.1 times 10 times the sine of theta, which is sine of 60. Okay, sine of 60. Because theta was given as 60, okay? The sine of 60 I'm talking about is for this, for Q. Now, this one will be equal to, of course, 0.1 plus 0.2, that one will give us 0.3 of A. You see that? Now we simplify this. You can see that actually there is acceleration, so the particles move. But let us simplify it. All on the left, we are going to have 1 minus 0.7 into 0.5, because if you get 10 times a half, you get 5, then times 0.1, you get 0.5. And then, what else? Then minus 0.1 times 10, that one will give you 1. Then times sine of 60 is root 3 over 2. Okay, we get that, then we divide by 0.3. So I can say acceleration is equal to 13 minus 10 root 3. Acceleration is equal to 13 minus 10 root of 3 out of, was it 6? So, meters per second squared. Then you can conclude, since there is acceleration, then the particles move. As simple as that. Part B, it is given instead that the plane BC is smooth. The particles are released from rest, and in the subsequent motion, the tension in the string is root of 3 minus 1 newtons. Find the magnitude of the acceleration of P as it moves on the plane, and find the value of theta. Now, going back to our diagram here, let's look at the forces which are acting on P. Okay, forces acting on P. Just zoom this one a little bit. So the forces acting on P, we can see them here, this and that. Okay, so we are going to go back here, and then we say that the forces that are acting on P, remember we are using F is equal to MA. So the net force is the 0.2 g sine of the theta 60 degrees, then minus the tension. Remember, it is this one minus this, because P is going down. Okay, all right, so minus the tension, which is given as root of 3 minus 1, then the mass of P is 0.2 times A. So meaning our A is going to be equal to 0.2 times 10, and then sine of 60 is actually root 3 over 2, then minus root 3 here, then plus 1, then we divide by 0.2. So putting this, all of it together in the calculator, what do we get? So I have 0.2 times 10, that one will give us 2. Divide by 2, 1. So we get root of 3. Then minus root of 3, you shall get 1. Then 1 divided by 0.2. Sorry, 1 divided by 0.2, I think that gives us a 5. Yes, 5. So acceleration here is equal to 5 meters per second squared. As simple as that. Then next, let us look at now the forces which are acting on Q. Again, we are using F is equal to ma, because they are telling us to find the theta. Okay, so when you look at the forces acting on Q, Q is going up. So we have the tension, then minus these two down here. Then we shall equate them to ma. Okay, so going back to this one here, we have the tension. Okay, we have the tension, then minus the mu r. But now this the plane is smooth BC. That means we don't have the mu r. Okay, so remove the mu r. That means we shall have now the two forces which are opposing each other. We have the tension and then the mg sine theta. So you shall have 0.1 then g sine of theta, which is equal to ma, which is 0.1 then a. So the tension is now given as root of 3 minus 1. Then here we shall have 0.1 times 10, which is 1. Then sine of theta. Then this one is 0.1. Already acceleration, we have gotten it as 5 because it is the same system. Okay, so the acceleration for P is the same for Q. Now we shall have root of 3 minus 1. I can bring this one this way, which is 0.5. Then this one will be equal to, I take this one this side to be a positive. Okay, 0.1 times 10, that is 1. So we shall have sine of theta. So meaning theta shall be equal to the arc sine of root of 3. And then here we shall have negative 1.5, right? Then minus 1.5. So what do we get? We put this in the calculator. Arc sine of root of 3, then minus 1.5. That is 13.4 to 1 decimal place. So theta is equal to 13.4 degrees to 1 decimal place. Always don't forget to put the degrees if you have worked out the answer in degrees. Question 7. A car of mass 1,200 kilograms is traveling along a straight horizontal road. The power of the car's engine is constant and is equal to 16 kilowatts. There is a constant resistance to motion of magnitude 500 newtons. Now, the stem of A and B, they are all under this. Constant resistance to motion 500. All right. Now, we are told to find the acceleration of the car at an instant when the speed is 20 newtons. Now, I have a car here, okay, moving maybe in this direction. That means there is a driving force. If it has power, there is a driving force. And then the resistance to motion is given as 500 newtons. You see that? Now, the power, we know it's the rate of doing work, and work is force times distance, then over time. But then distance over time is speed. So that means power is equal to Fv. So F is our driving force, then times the speed. So the driving force here is now going to be equal to the power, which is 16,000. You have to use watts, not kilowatts. Then divide by the speed, which is given as 20. This one will go. And then we get our answer as 800 newtons here. Now, we can use F is equal to ma. So ma, we are going to have now the driving force minus the resistance force. That is the net force that takes the car forward. Then is equal to the mass, which is 1200. Then times the acceleration, which we are looking for. So the driving force is 800 minus the 500. Then I will divide by 1200. Yes, just 2 zeros, which is equal to A. Now, this one is going to be 300 divided by 1200. These ones will cancel. 3 over 12 is the same as a quarter. So meaning acceleration is equal to 0.25 meters per second squared. Just like that. Then part B, assuming that the power and the resistance forces remain unchanged, find the steady speed at which the car can travel. Steady speed is the same as constant speed. So this means that acceleration is equal to 0. Remember, power is equal to the driving force times the velocity, right? So that means the new driving force is going to be that power which is unchanged. Then we divide by the steady speed, which we don't know. Okay. Now, F is equal to ma. For the constant speed or steady speed, the driving force will always be equal to the resistance force, because we are going to have the driving force here. You see that? Then minus the resistance force, then is equal to ma. And if this one is 0, then the driving force, which is 16000 over V, shall be equal to the resistance force, which is 500. You see that? Because this one is 0. Then what will be our V? Cross multiply. So you have 16,000, then divide by 500. This one will give us our V. So this one, the 2 zeros will cancel. And then our V, 5 goes into 16 3 times. Then remember 1, you put it here. Then 10 over 2, that is 2. So that means V is equal to 32 meters per second. As simple as that. The car comes to the bottom of the straight hill of length 316 meters, inclined at an angle to the horizontal of arc sine of 1 over 60. That means sine of that angle is equal to 1 over 60. Okay. The power remains constant at 16 kilowatts, but the magnitude of the resistance force is no longer constant and changes such that the work done against resistance force in ascending the hill is 128,400 joules. The time taken to ascend the hill is 15 seconds. This is very important. Now, I'm going to use the energy method, but I will do a sketch here. Okay, so the car, let's say the car now has traveled up the hill here. Okay, it was down here, and the distance here is 316 meters. There, the whole of this distance. And then this one takes 15 seconds, okay, to move in there. Now, I have an angle of inclination here, theta. Then it comes at they said that the car is traveling at a speed of 20 meters per second at the bottom of the hill. So I can say my u here is equal to 20 meters per second. So meaning, because it has the speed, then here it has kinetic energy. Okay. Then when we come up here, because there is generation of this vertical height here, then it will have the potential energy. And since we are told to find the speed at the top of the hill, that means there is also kinetic energy here, because kinetic energy is dependent on the speed. Okay. Then there is an H here, and using SOHCAHTOA, okay, using SOHCAHTOA, sine of theta is equal to opposite over hypotenuse. So sine of theta is equal to the opposite, H, over the hypotenuse, which is 316. So meaning our H is going to be equivalent to 316 sine of theta. Why am I finding this H? Because I'm going to find potential energy, and potential energy is mgh. Okay, potential energy is given by mgh. Kinetic energy is given by a half mv squared. So this one is equal to 316 sine of theta. And remember, sine of theta was given as 1 over 60. Now, having put all of that down, we use the work energy principle, which says that work done by the driving force, work done by the driving force, okay, minus work done against resistance, work done against resistance, then is equal to the change in mechanical energy. I've always explained and said you have the particle here, maybe it is moving here. So it has a driving force which takes it forward, okay? So that is the work done by the driving force. But as it is doing so, it has resistance to that motion. So you have to also work against that work. I mean against that resistance. So that's why we subtract the work done against the resistance. And then after that, it is changing the speeds from here to there. So it is equal to the energy change here. So the change in the mechanical energy. So that's why we have something like that there. Now, what is the work done against, work done by the driving force? Do we have the driving force? No, here we don't know the driving force. But they told us here that work done against resistance is 128,400. This one here. Now, I want us to identify a few things here. They gave us the work. Power the power remains at 16 kilowatts. Now, we know that, in fact, let me just put it here. We know that power is equal to the rate of doing work. So I will say work done by the driving force, it is the one that I'm looking for. Then divide by the time taken. And work is 16,000. The power, 16,000. Then work done by the driving force, where is it? Is the one we are looking for. How about the time taken? They gave us the 15 seconds here. That means I will come here and I put the 15, okay? So when I cross multiply, that one will give me the work done by the driving force. So I come here and I say 16,000 times the 15. That is the work done by the driving force. Then work done against resistance was given as 128,400. So minus 128,400. Then change in mechanical energy. You get the final mechanical energy. And remember, mechanical energy is equal to the sum of the potential energy and the kinetic energy. So here we have the two. I'll put potential energy, which is M, okay? M, what's the mass of the car? The mass of the car was given as 1,200 kilograms. Okay, so 1,200 kilograms, M, 1,200 kilograms times G, then times H, which H is this one here, which is 316. Sine of theta is 1/60. Okay, then plus a half, the M is 1200, a half mv squared, and this is the v we are looking for. Then minus, we shall get the initial kinetic energy. So this is final, then minus the initial, okay? Then we shall have a half times 1200, then times the 20 squared. So on the left, when we simplify, what do we get? We have 16,000 times 15, then subtract 128,400. This one gives us 111,600. So 111,600. Then we go to the right, 12000, then times 316. Then we divide that by 60. Okay. And then I can subtract right away 0.5 times 1200 times 20 squared. So all of it together here, it will give me negative 176,800, negative 176,800, and then plus a half of this one, of course, that will be 600. So 600 V squared. So we make this be the subject of the formula. So we shall have 11600, then plus 176,800. Then we shall divide by 600. Then after we take the square root, this will give us the value of V. So therefore, what is the value of V? Square root of 11600, then plus 176,800, and then we divide by 600. And then we get our answer as 21.9 to 3 significant figures. 21.9 meters per second to 3 significant figures. So that has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.